Good morning, students. Chapter 4, Motion in a Straight Line. Last lecture we have discussed about cross dot product, scalar product. Okay, whenever we multiply two vectors and if your answer is only magnitude, means scalar, such type of product is called scalar product. It is also called dot product. Okay, and it is represented by putting dot between two vectors. Yes, we know its equation. A dot B is equal to AB cos theta. Another definition, magnitude of one vector into projection of another vector on first vector. Then properties, yes, properties of scalar product. Remaining two properties we will discuss today. Okay, see what is property. If you are given vectors in terms of components, if you are given vectors in terms of components, then how to find its dot product? Then how to find its dot product? For example, if we have vector A is equal to AXI caret plus AYJ caret plus AZ K caret. Okay, for three dimensional motion we can write A is equal to AXI plus AYJ plus AZ. Okay, and let another vector B is equal to it is BXI plus BYJ plus here it is BZK. Clear about this? So yes, we are assuming two vectors A and vector B. Now we will take that dot product, that is A dot B. See how to write. A means first vector AXI plus AYJ plus AZK dot another product, another vector BXI plus BYJ plus BZK. Clear about this? Okay. Now how to simplify? See, whenever you multiply two bracket, you know how to open that bracket. Okay. First of all, we will multiply this AXI dot with BXI, with BYJ and with BZK. See how to write. See, AXI caret dot BXI caret. Clear about this? Clear about this? Then plus AXI dot BYJ. Clear? Plus AXI caret dot BZK caret. Okay. Similarly, now we will take dot product of AYJ with this three term. So plus AYJ dot BXI plus AYJ dot BYJ, AYJ caret dot BYJ caret plus AYJ caret dot BZK caret. Clear about this? Now we will take dot product of this AZK with these three terms. Okay, so then it is plus AZK dot BXI caret plus AZK dot BYJ caret plus AZK dot BZ. Clear about this? So yes, it is very long term. Okay, now in the last lecture we have discussed one important property, that is I dot I is equal to 1, J dot J is equal to 1, K dot K is equal to 1. Also I dot J is equal to J dot K is equal to K dot I is equal to 0. So here how to simplify this? See this last step is equal to AXI dot BXI. So I can write AX and BX, they are magnitude, so we can multiply them directly. Okay. Remaining is I caret dot I caret, and I caret dot I caret is 1. Clear about this? Clear about this? Plus AX BY. But what is remaining? I dot J. And yes, in last lecture we have discussed I dot J is equal to 0. Plus in this case it is I dot K caret, it is again 0. Yes or no? Yes. Then for this term, Ayj dot Bxi, j dot I, it will be 0. Ayj dot Byj. Yes, j dot j. And we know that j dot j is equal to 1. So I can write it is Ay By. And here it is 1. Last term, again, Ayj dot Bzk, j dot k, it is 0. So yes, here it is 0. Okay, and now for this term, Azk dot Bxi, k dot I, yes, k dot I is 0. Azk dot Byj, k dot j, yes, it is again 0. And last term is Azk caret dot Bzk caret. So what is its answer? Az, Bz, 1. Yes or no? So finally, what you have to remember? You have to remember A dot B is equal to Ax, Bx plus Ay, By plus Az, Bz. In short, how to remember? Dot product means product of x component plus product of y components plus product of z component. Clear about this? And see, it is only Ax, Bx, product of magnitude, Ay, By, Az, Bz. Yes or no? Yes. Okay, so there is no I caret, no j caret or no k caret, means no direction. A dot B dot product, scalar product, it gives only magnitude. It gives only magnitude. Clear about this? Okay, so yes, it is one important property of scalar product. Now last property, to find angle between two vectors. To find angle between two vectors. How to find angle between two vectors? See, we know what is A dot B. A dot B is equal to, it is AB cos theta. A dot B is equal to, it is AB cos theta. So if I make cos theta as subject, then cos theta is equal to, it is A dot B upon AB. A dot B upon A. Clear about this? So yes, if I make theta as subject, then it is cos inverse A dot B upon AB. And yes, with the help of this equation, you can find what is angle between two given vectors. What is angle given between two given vectors? Okay. So yes, these all are properties of scalar product. In last lecture, we have discussed about 1, 2, 3, 4, 5, 6, 7 properties. Okay, and it is another 2 properties. Clear about scalar product? Okay. Now we will see some examples. See how to take. Okay, this scalar product. If I have one vector A, vector A is equal to 3i plus 2j plus 2 caret. Okay, and vector B is equal to, it is 2i caret plus 3j caret plus 2k caret. Clear about this? Then how to find its scalar product? Okay, A dot B. See, hello students, it is theory. What is conclusion of this theory? This equation. Yes, we have to use this. A dot B is equal to Ax Bx, product of x component, plus Ay By, product of y components, plus Az Bz, product of z components. So here it is. See, vector A, vector B, Ax, Ay, Az, Bx, By, Bz. So yes, use this method. Ax, Bx, 3 into 2, it is 6. Clear about this? Only 6. No I caret. Okay. It is 3 into 2, it is 6. Plus 2 into 3. Yes, it is again 6. Plus 2 into 2, it is 4. So it is 6 plus 6, 12 plus 4 plus 4, it is 16. So your answer is 16. See, 16. Only number, real number. So yes, it is only magnitude, scalar product, dot product. Clear about this? Okay, so how to find this dot product? It is simple. Okay, it is very easy. A dot B, A dot B. Clear about this? Okay, now we will see another example. See, okay, if you are given two vectors, then how to find angle between them? Then how to find angle between them? Okay, we are taking two vectors. We are taking two vectors. First vector A is equal to, it is minus 2i caret plus 2j caret minus 4k caret. And another vector B is equal to, 2i caret plus 4j caret minus 2k caret. Okay, we are given two vectors A and B, and your question is find angle between them. Find angle between them. How to find angle between them? See, yes, we have this equation. If you are given two vectors A and B, then how to find angle between them? Cos theta is equal to A dot B upon AB. Cos theta is equal to A dot B upon AB. See, cos theta is equal to, it is A dot B. Here it is upon AB. A dot B means dot product of two vectors. See how to find dot product of two vectors. You know it. Okay, we will find directly. Minus 2 into 2. Minus 4. Plus 2 into 4. 2 into 4. It is 8. Minus 4 into minus 2. Yes, it is plus 8. Clear about this? Clear about this? Okay, again. Minus 2 into 2. Minus 4. 2 into 4. 8. Minus 4 into minus 2. Here it is 8. Divided by A means magnitude of vector A. How to find magnitude of this vector A? See, it is under root minus 2 square plus 2 square plus minus 4 square. Clear about this? Yes. If you are given vector in 3 dimension, how to find its magnitude? Under root ax square plus ay square plus az square. For this vector B, what is? It is 2 square plus 4 square plus minus 2 square. Clear about this? Clear about this? Okay. Now, yes, 8 and 8, 16. 16 minus 4, yes, it will be 12. Yes or no? Yes, it is. Divided by under root 2 square, 4. 2 square, 4. 4 square, 16. Clear about this? Divided by 2 square, 4. 4 square, 16. 2 square, 4. Okay, now 16 plus 4, 20 plus 4, 24. So is equal to 12 upon root 24, and here it is also root 24. So it is 12 upon 24, so it is 1 by 2. So now cos theta is equal to 1 by 2. And now you know, okay, that 1 by 2 value of cos theta is when angle theta is equal to, what is value of angle theta? Yes, write your answer in comment box. Okay, what is value of angle theta? Now with this, yes, it is scalar product. Now we will see one of the most important topic, vector product, dot cross product. Okay. Okay students, now we will see what is vector product. In scalar product, yes, we know that in scalar product your answer is only magnitude. Okay, without direction, without I caret, j caret or k caret or any unit vector. But what is vector product? Vector product is whenever two vectors we multiply and its answer has magnitude and direction both. Magnitude and direction both. Then such product is called vector product. Okay, such product is called vector product. For example, we are taking two vectors. Let vector A and B are in a plane. Angle between them is theta. Angle between them is theta. Okay, then how to find cross product between them? Vector product vector product between A and B, vector product between A and B is defined as A cross B. A cross B. A cross B. See students, remember, okay, whenever you have vector product between two vectors, you have to put cross sign between them. You have to put cross sign between them. That's why this vector product is also called cross product. It is also called cross product. Okay, so yes, it is A cross B. Now what is its value? A cross B is equal to, it is AB sine theta n caret. It is AB sine theta n caret. A cross B is equal to AB sine theta n caret. A cross B is equal to AB sine theta n caret. Where? This term indicates its magnitude. It is its magnitude. And this unit vector n caret, it indicates its direction. It indicates its direction. So yes, it is difference between scalar product and vector product. In scalar product, A dot B is equal to AB cos theta only magnitude. But in cross product, in vector product, we have A cross B is equal to AB sin theta n caret. Okay, where theta is angle between two vectors, A and B magnitude. N caret, what is n caret? N caret is unit vector in the direction of A cross B. Okay, here what is n caret? See, here what is n caret? N caret is unit vector. N caret is unit vector in the direction of A cross B. In the direction of A cross B. And it is perpendicular. It is perpendicular to plane of vectors A and B. Okay, yes, it is magnitude. How to write its magnitude? See, its magnitude I can write like this. Its magnitude I can write like this. Mode of A cross B. Mode. Hello students, what is meaning of mode? Yes, you know. Magnitude. Mode of A cross B means magnitude of cross product. Yes, it is magnitude of cross product. So it is AB sin theta only. So what is difference between these two equations? See, A cross B means it is vector, and vector is always represented as product of magnitude and unit vector. But here it is magnitude. So mode of A cross B is equal to, it is AB sin theta only. Clear about this? Now the most difficult thing, okay, and important thing for this cross product is this. Yes, this direction. How to find direction of cross product? How to find direction of this cross product? See, in 11th and in 12th. Okay, you will have chapters based on this direction. So yes, it is very important how to find direction of this vector product. Okay, yes, it has one particular method and it is called right hand screw rule to find direction of vector product. Which method is used? Right hand screw rule. So see, now we will see that method in detail. Right hand screw rule method. To find direction of vector product. Okay, how to find direction of vector product? See, I am taking two vectors. Okay, like this. It is first vector A. It is another vector B. In plane of God. Yes, I have two vectors A and B in plane of God. And I want to find find direction of A cross B. A cross B. See, here order of cross product depends. Okay, A cross B. A cross B means first vector is A. First vector is A. Alright, always A is first. Okay. So here, yes, first vector is A. A cross B. We have to find its direction. What you have to do? What is method? Yes, method is first method. It is right hand screw rule. Right hand screw rule. What you have to do? See, these two vectors are in plane of God. Clear about this? Hold screw in your right hand. Hold screw in your right hand. Yes, it is right hand. Hold screw in your right hand. But how to hold? See, you have to hold this screw perpendicular to plane containing A and B. This A and B, they are in plane of God. So what you have to do? You have to take screw in your right hand perpendicular to this board like this. Yes, it is perpendicular to board. Yes or no? Yes. Now you have to rotate this screw from A to B because we have to find direction of A cross B. So rotate screw from A to B. Put screw like this, hold screw like this, and now rotate that screw in this direction from A to B. From A to B. Yes or no? From A to B. Okay, so yes, if you hold screw like this and if you rotate it, screw will advance in one direction. Screw will advance in one direction. It will move in one direction. In which direction? See, if I rotate screw in this direction, yes, it is anti-clockwise direction. Means it will move towards you. It will move towards you. It will move towards you. Yes or no? Yes or no? Okay, means when we rotate screw in this anti-clockwise direction, screw will move outward. Screw will move outward. So what is direction of cross product? Perpendicular to board. Perpendicular to board coming outside. Coming outside. See, I am writing right hand screw rule. First, hold screw in right hand. Hold screw in right hand perpendicular to plane of A and B. A and B. Now rotate screw from A to B. From A to B. From A to B means like this. If you are holding screw like this, you have to rotate screw from A to B in this direction. Okay. Then advancement of screw. Advancement of screw gives direction of A cross B. Direction of A cross B. Okay, so yes, it is right hand screw rule method to find direction of vector product. Okay, where is now in case of screw, sir, how it is moving in upward direction, how it is moving in downward direction. Yes, we also have one easy method. It is called only right hand method. See how? Right hand, open your palm, open your palm. What is first vector? A. First vector is A. First vector is A. Put this right hand, okay, in direction of first vector, that is vector A. Clear? Clear. What is second vector? B. And it is in upward direction, so you have to sweep your fingers in direction of B. Clear about this? Then this stretched thumb, this thumb indicates direction of vector product. See, this thumb is perpendicular to board coming outside. Perpendicular to board coming outside. Again, repeating. See, repeating. You have to find A cross B. Put your right hand in direction of A. Put your right hand in direction of A. Another vector is B and it is in upward direction. So wrap your fingers towards B. Wrap your fingers towards B. This thumb indicates direction of vector product. See, right now this thumb is perpendicular to board coming outside. So yes, it is direction of A cross B. It is direction of A cross B. So in this case, A cross B is perpendicular perpendicular to plane of page. Yes, you have to write in notebook. So it is perpendicular to page outward. Clear about this? A cross B is perpendicular to plane of page outward. Clear about this? Now it is direction of A cross B. How to find direction of B cross A? How to find direction? How to find direction of B cross A? Hello students, you have to use the same method. See, here it is. Vector A and vector B. Vector A and vector B. How to find direction? First of all, see this matrix is easy. Put your hand in direction of first vector. First vector is vector B. Yes, it is vector B. Yes, it is vector B. Okay. Now you have to rotate your fingers. You have to sweep your fingers from first vector to second vector. From first vector to second vector. Now see, I am not that flexible. Okay, I can sweep my fingers like this. Yes, you cannot. Okay, so yes, you have to adjust your hand like this in direction of vector B. Now yes, your right hand is in direction of vector B. Now sweep your fingers towards A means in this direction. So yes, thumb is perpendicular to board going inside. Clear about this? Again, first of all, put your right hand in direction of vector B. Then sweep fingers in direction of vector A, towards vector A. Then this thumb gives direction of B cross A. And see this thumb, you can't see, but I can see. Okay, it is perpendicular to board going inside. Okay, so yes, it is method how to find direction of cross product. So here B cross A is perpendicular to plane of page inward. Clear about this? So from this discussion it is clear A cross B and B cross A, they are not in same direction. See, here it is. A cross B is perpendicular outside. While B cross A is perpendicular inward. Means these two vectors are in opposite direction. It is A cross B, it is B cross A. Clear about this? So yes, if we discuss properties of vector product, okay, if we discuss properties of vector product, then what is first property? Yes, here it is. A cross B is not equal to B cross A. Why? Because vector quantity means magnitude and direction both. If both magnitude and direction both are equal, then two vectors are equal. Otherwise they are not equal. Here A cross B and B cross A, they are not in same direction. Yes, their magnitudes will be same. But the direction is not same. The direction is opposite. So we cannot write A cross B is equal to B cross A. Okay. Yes. How to write this? I can write this as A cross B is equal to minus B cross A. Why minus? This minus sign indicates that direction of this vector and direction of this vector are in mutually opposite direction. So it is how to write vectors. Yes, A cross B and B cross A, their magnitudes are equal, but the direction is not same. The direction is opposite. So you have to write like this. Clear about this? Okay, now yes, as we have discussed properties of scalar product, maybe 7 to 8, we have to discuss property of vector product. Okay, that we will discuss in next lecture.